Okay, so for the bell ringer, it says, when you float in water, what force pulls you down? What force keeps you from sinking? Are these forces balanced or unbalanced? Explain your answer by either typing or using the microphone. All right, so what we're going to do, I guess first of all, actually, let's see here. There it is, bell ringer. All right, first of all, I have 18 students in class, actually 17, and only 5 of y'all have done the bell ringer. So please make sure you get the bell ringer done. All right, so let's go ahead and draw what's called a free body diagram. So if you could, go to your science spiral, and you're going to write this down. This has to do with the person floating in water. Let me get back to, let's see. Try opening this again. Third, third. All right, looks like I need to make one more copy. We'll use 6th grade. Okay. So for the bell ringer, here it is. Let me add a page. There we go. All right, for the bell ringer, you have a person floating in water. The question is, what force pulls down on them, and what force keeps them floating? So I guess first question, if you're floating in water, what force pulls down on you? Anybody?
Gravity.
Very good, gravity, okay. So yes, the force of gravity pulls down on you. So gravity, by the way, is a pulling force, not a pushing. So I'm going to show gravity pulling down on a person floating. I'm going to label that as the F of G, the force of gravity. Next question, a little more difficult, is if you're floating, what force pushes up on you? Does anybody know that one? If you're floating, what force pushes up on you?
I think it's friction.
Good guess. Friction is the force that opposes motion. So if you're riding your bike down the hill, yes, friction would slow you down. But if you're floating in water, it's a term related to buoyancy. Anybody know what that might be? It's actually called the buoyant force. Okay, so if you're floating in water, the force of gravity pulls you down, whereas the buoyant force pushes up on you. That's the F of B. So the buoyant force. Okay, so question is, if you don't sink, in other words, you're floating, is this a balanced or an unbalanced force? And the answer is that would be a balanced force. So this is a balanced force because he doesn't sink in the water. And let me go back, read the exact question. It says, when you float in water, what force pulls down on you? That's the force of gravity. What force keeps you from sinking? That is the buoyant force. Are these forces balanced or unbalanced? And these forces are balanced because balanced forces do not result in a change in motion, whereas unbalanced forces do result in a change in motion. And in this case, he's not changing his motion, he's not sinking, So the force of gravity is equal to the force of buoyant. Oh, let me go ahead and spell that for you. B-O, the buoyant force. Okay? Again, this picture here is called a free body diagram. It's what we use in physics to kind of show the problems that we're solving. When you get to high school, and if you take physics in college, you could be doing some extremely complicated problems with a lot of math work, and you'll still draw these little simple diagrams, because what you can often do is do a free body diagram, and then you might go do, if you're in high school or college, you might go do 2 or 3 pages of math work, and then you can go back to your diagram and ask yourself, does that make sense? Does my answer, all that math work that I do, match the picture that I drew? So you will use these free body diagrams later on in your science career. You'll definitely use them in high school and in college when you take physics. So what we're going to do today is we're going to finish up our notes. So everybody should have their science spiral out. And we're going to draw some free body diagrams. Okay, first let's finish up the definitions. First definition is a vector. A vector is a combination of a size and a direction of a force. Okay, so a vector, and again, when you take notes, you don't have to write any words. You just write the size and direction of a force. You don't have to write the whole definition. Okay, so, and it says draw some examples of vectors. Well, you can draw that. That's one example of a vector. 5 newtons to the left. Alana, do you have a science spiral? Alana. Science problem? Huh? You have a science problem? We're taking notes. So we're going to be drawing free body diagrams. Are you on Zoom yet? I don't think you are. Go ahead and get on Zoom. We're drawing, taking notes on Zoom. Okay, so 5 newtons to the left. 5 would be my force. To the left would be my direction. That makes a vector. A vector is a force with a direction, or a size and a direction. Let's draw some other examples of vectors. Alana, are you logging into Zoom? Yes. All right. We're taking notes right now. Okay, so some other examples of vectors. 5 newtons to the left would be a vector. We can also write it like this. 5 newtons.
Are you supposed to be sharing your screen?
Yes, I am. Thank you for...
Oh, it's not showing.
Yeah, I'm surprised. First person to say anything. Actually, was I sharing my screen when I showed y'all the person floating in water? No?
No, the whole time I wasn't sharing the screen.
Okay, let me go back to that. That was kind of quiet. All right, you need to write this down in your notes. This is the warm-up. Actually, I thought y'all watched me draw this whole thing. I guess not. Here we have a guy. Go ahead and draw this picture. Here we have a guy floating in water. The force of gravity pulls down on the guy. The buoyant force pushes up on the guy. Okay, so the question is, what 2 opposing forces exist when a man floats in water? This was your bell ringer. That would be the force of gravity and the buoyant force. They are equal and opposite forces. And they are balanced forces. And the reason they are balanced forces is because he does not move. Okay? If he was to move or change his speed, it would be unbalanced. But because he's just floating in the water, that is a balanced force. So again, it's F of G stands for force of gravity, and then F of B, or I wrote F of buoyant. All right, I would assume y'all saw that, but what I was trying to do is get my screencast going along with the notes, so I was sharing the wrong screen, I guess. Okay, so going back to the one I just started on, so let's take a few more notes, and then we're going to do some free body diagrams. Okay, so a vector. A vector is a size of a force and a direction. So example, 5 newtons to the left. Give me the pencil. Right there by the pencil sharpener. Okay, so 5 newtons to the left. 5 is your force. To the left is your vector. Or we can write it like this. 5 newtons to the left. Five is your force. To the left is your direction. That makes a vector. So again, make a little section called vectors, because what we're doing is drawing vectors. Another way I could write this, I could say 3 newtons to the north. Okay, 3 newtons, that's my size. To the north, that's my direction. That makes a vector. It's a size with a direction. Seems pretty simplistic, which it kind of is, but when you get to high school, it becomes a lot more complicated. There's a lot of things you can actually do with this once you're in high school. How is it? On the wrong page here. Okay, just kind of going through my attendance. People I'm missing. I'm missing Josiah, Jaime, Caitlin, Caitlin Hallgreen. Yeah, you're here. I got Caitlin, okay.
Hold on, I'm writing it down.
Alana's here. Alejandro, are you here? And, okay. Another way we could draw a vector, so we could say 5 newtons with the arrow to the left. We could say 5 newtons to the left. We could say 3 newtons north. Another example of a vector would be, let's say, 8 newtons down. So let's say, a rock moved down a hill with a force of 8 newtons. That would be a vector because it gave us a direction. As long as it gives you a direction, you have a vector, which is a force with a direction. So 8 newtons is your force, down is your direction. That gives you a vector. Okay, so next definition is a net force. A net force is a sum of all forces. And that's all you need to write. You don't need to write every single word. You could draw this truck right here. So for example, here's my truck. If a force pushes on a truck of 2 newtons, that would be probably my force of friction. And the truck pushes down the road with a force of 5 newtons. Question is, what is my net force? Well, first thing I ask myself is, are they working together? Are they working together or against each other? I would say they're working against each other, so I'm going to subtract. So I would say 5 minus 2 gives me 3 newtons. So I come over here, I would write 3 newtons to the left. Okay, so net forces are the sum of all forces applied to an object. In this case, the sum here is 3 newtons to the left. What that tells me is that this truck will accelerate to the left. It's going to move to the left with a force of 3 newtons. When you get to high school, they'll give you masses, and you can actually determine how fast it will accelerate, how fast will it move. All right, so that's a net force. A net force is right here when you add them up and you get your answer. It's basically your answer to the problem. If net forces are not zero, they're called unbalanced. In this case, the truck would begin to accelerate. Okay, the next definition is a balanced force. A balanced force is when net forces are equal and there is no change in motion. So for example, let's say I have a box and I push on the box with 2 newtons and somebody pushes in the opposite direction with 2 newtons. Well, what's 2 minus 2? 0, right? So my net force is 0 newtons. And actually, let's put that right here. Balanced forces are always equal to 0 newtons. That's a 0 newtons. So in other words, it's not going to move. There is no change in motion. Okay, so with balanced forces, there is no change in motion. Number 4, or I should say next definition, is a unbalanced force. Unbalanced forces are not equal to 0, and the object will change motion or accelerate. So you could just write, if I was writing notes, what I'd write is unbalanced forces are not equal to 0, and the object will accelerate. In other words, it's going to speed up. So, example, let's say I have a ball. Someone pushes on that ball with 2 newtons of force. And I push on the ball with 6 newtons of force. Well, because we're pushing opposite directions, we're going to subtract. So 6 minus 2 gives me a net force of 4 newtons. All right, so my answer is unbalanced forces, for an example, is not equal to 0, like 4 newtons, and it will accelerate. In other words, if I'm pushing harder, the ball is going, and actually I would need a vector, which is a direction. The ball is going to accelerate to the left with a net force of 4 newtons. All right, and it's really pretty simple. If they're, one second, let me change my screen here. If they're pushing against each other, you're going to subtract because they're working against each other. If they're working together, you add. But in this case, they're working against each other, so it's going to subtract. So, that's that. So unbalanced forces cause objects to accelerate. In other words, they're going to speed up. All right, so number 1, let's do some practice problems. We want to say 3 things. First, what's the net force? Second, is it balanced or unbalanced? And then third, what is its motion? All right, so first thing. First problem. Penelope, are you there?
Yes.
So Penelope, are these 2 objects working with each other or against each other?
Against each other.
Okay, so do you think we're going to add or subtract?
Subtract.
Very good, we're going to subtract, okay? Go ahead and draw this picture. draw a ball with two arrows pushing on the ball. One pushing with 50, the other one pushing with 10. All right, and then let's go ahead and subtract 50. Show your work. That way later when you study your notes, you know how you got to this answer. So because they're working against each other, we're going to subtract. 50 minus 10 is 40. 40 what? 40 newtons. Okay. So my answer is 40 newtons. And then the question is, well, what direction will the ball move? And what I always tell students is just look for the bigger number. There's my bigger number. It's going to move to the left. All right. In fact, it's going to accelerate.
You mean to the right?
Yes, to the right. Correct. It's going to go to the right with a force of 40 newtons. When I say go to the right, it's actually going to accelerate. In other words, it's going to get faster. It will accelerate until the net force reaches 0. Okay, next thing, is that balanced or unbalanced? Well, it's not 0, and because it's not 0, it is unbalanced. Actually, I'm going to start typing because this Jamboard is convenient, but it's hard to write with. So it is unbalanced, and what is it going to do? It is going to accelerate to the right. Okay. And again, when you get to high school, there's all types of problems you'll be working using these things. There's actually, well, anyways, there's all types of problems you can do in physics with these. Okay, next one, number 6. There's a skater. Let's draw the skater. I'm just going to draw them with you. Just on free body diagrams, you don't have to be fancy. All right, there's my skater. He's pushing with an input force of 20 newtons. So 20 newtons. I'm going to put a little I to show that that is his input force. And the force of friction, friction being the force that opposes motion, the force of friction is 20 newtons. And I'm going to put a little F to show that that's the force of friction. Okay, the next thing I ask myself is, are they working together or are they working against each other? So Connor, are they working together or against each other? Is Connor there? Let's see. Who wants to try this out? Are they working together or against each other? What do you think, Aaliyah? Are they working together or against each other? Let's do this. Everybody thumbs up if you can hear me right now. Kind of quiet out there. Oh. There's Connor. Hey, Connor. Are they working with each other, or are they working together or against each other?
Mr. Leonard, can I answer?
Yes, you can.
They're working together.
Okay, well, are the arrows pointing in the same direction or opposite directions?
Same.
This one points to the right.
Wait, they're pointing opposite.
Opposite. So you think they're working together or against each other?
Against each other?
Yeah, they're working against each other. So are we going to add or subtract?
Subtract.
Very good. We're going to subtract. So 20 minus 20 is 0. Okay? So yes, his net force is 0 newtons. And we're not always going to write this, but right now we'll go ahead and do it. Net force. Basically, that means your answer. What is your answer? Well, his net force is 0 newtons. And he's going to move at a constant motion. So in other words, is he going to stop moving? No. He's going to keep moving. He's just going to keep moving at a constant speed. So he's going to keep moving at a constant speed because his net force is 0. In other words, he's not going to go any faster. He's not going to go any slower. Because the net force is 0, he just continues doing what he's doing. Okay, number 7. Let's draw a roller coaster. So, everybody draw a roller coaster. This is my roller coaster. Again, it does not have to be pretty. Okay, so on this roller coaster, the force of gravity pulling down on the roller coaster is 1,000 newtons. Okay, the force pulling down the roller coaster is 1,000 newtons. The force that opposes the roller coaster, actually, I'll finish this. 1,000 newtons downwards is the force of gravity. That's what I meant to say. So the force of gravity pulls down on the roller coaster. And what opposes that is the force of friction. Here's the force of friction right there. Let's see. Right here, the arrow going upwards. It's 300 newtons. So what opposes the force of gravity is the force of friction. And it pushes up with a force of 300 newtons. Okay, so are these working with each other or against each other? Aaliyah, what do you think? Are they working with each other or against each other? Anybody? Yes,
They're working against each other?
Very good. They are working against each other. So I'm going to subtract. So let's come over here and we'll put, 1,000 minus 300. What is 1,000 minus 300? 700. 700 newtons. All right, that is my net force. So my net force is 700 newtons. And I always tell students to look at the bigger number. There's the bigger number. So what direction? Down. Okay. So next thing, let's describe bounce or unbounce along with the motion. So it is a unbalanced force. And it's going to move down. And it's going to accelerate. In other words, it's going to get going faster. It will accelerate. In other words, it's going to get going faster. It's going to speed up. So it's an unbalanced force. In other words, it's not 0. which means it's going to accelerate. In what direction? It's going to go down the tracks at a faster rate. Okay, that's what we have time for today. We will finish this tomorrow and then take a short quiz over it. I will see y'all tomorrow. Have a nice day.
Bye, Mr. Leonard.
Take care.
Bye, Mr. Leonard. Have a good day.
You too. Bye.